Now this is a redox equation. We are given two half equations here, one for the reduction and another one for oxidation. And then they also give us an overall equation, okay, from these two half equation here, the overall. And if we look at the statements 1, 2, and 3, they want us to pick the correct one. So number one, u equals to x equals to z. That means we have to balance this equation to be able to check if statement number one is correct. Number two, manganese is reduced to oxidation state plus 4. Number three, sulfur is oxidized from oxidation state plus 4 to plus 6. So that means we have to find the oxidation state of manganese and also sulfur from the equations. Now that means we are going to use this overall equation a lot. So I am going to copy this equation one more time, okay, on top here so that we can use it more than once. Okay, now first of all, uh, redox, right? So we need to find the oxidation state for manganese and sulfur to check statement number 2 and 3 whether they are correct or not. So I'm going to use the half equation. So manganese in this manganate ion, right, has a plus 7 oxidation state. Now how do I get this? I assume that I do not know the oxidation state of manganese, so I put it as X. So X is the oxidation state of manganese. Now oxygen here always has negative 2 oxidation state, so there are 4 oxygen. So multiply by 4. Now overall charge is negative 1. So from here, I'll be able to rearrange and find the oxidation state of manganese, which is plus 7. Okay, so manganese has a plus 7 oxidation state in this manganate ion. In the product, okay, manganese oxide, here again, I'll assume this manganese as X again, right? X plus negative 2 oxidation state of oxygen multiplied by 2 because 2 oxygen here. Now overall charge is 0 because a neutral compound, so X is plus 4. So manganese is reduced to plus 4, from plus 7 reduced to plus 4. So can you see that statement 2 is correct? Manganese is reduced to oxidation state plus 4. Okay, let's take number 2 first. Now, let's find the oxidation state of sulfur, okay, in the reactant and also product in the second half equation. Now, use the same method. I'm not going to repeat here. Okay, you can try later. So this is plus 4 in sulfide ion. In sulfate ion, sulfur has a plus 6 oxidation state. So sulfur is oxidized from plus 4 to plus 6. Oxidation number increases, that means it is an oxidation. Now in previous case, oxidation number decreases, plus 7 to plus 4, okay, decreases, so reduction. Now both statement 2 and 3 are correct, okay, so now you can rule out that B and C are not the answer. So now all depends on whether the first statement is correct or not. So from manganate ion to manganese oxide, oxidation number change from plus 7 to plus 4. So the change is minus 3. Okay, plus 7 minus 3, okay, you get plus 4. So the change is negative 3. Now, whereas for sulfide to sulfate, okay, oxidation number decreased by 2. Plus 4 plus 2, you get plus 6. So now this one is a simplification. Okay, there's a transfer of electrons between these two species so that their oxidation number can change. Okay, so we want to make these two magnitudes the same. Okay, now this magnitude is 2, this is 3. So we have to multiply this by 3 multiplies this by 2 so that we get the same magnitude. 6, okay, this one also 6. Now, since I multiply this by 2, meaning, okay, U is 2. Okay, this whole thing, okay, that means I need 2 manganese ions. Okay, same goes to manganese oxide. Okay, X is 2 because multiply by 2, I need 2 manganese oxide. So we follow, okay, we follow the factor that we multiply. And for sulfide, okay, multiply by 3, so W is 3. Okay, Y is also 3. Okay, so okay, I'm going to rewrite the whole thing. Okay, 2, 3, 2, 3. Okay, now I have to count the total number of oxygen on the left and on the right so that I can balance the equation, because we have V and Z left to balance. So 2 times 4, 8 oxygen. 3 times 3, 9 oxygen. Okay, here I have 2 times 2, 4 oxygen. 3 times 4, 12 oxygen. So now I have 17. Here I have 16. Okay. Now in these two, water and hydroxide ions, okay, there's only 2 H from one H2O molecule. Here 1 hydrogen from 1 hydroxide ion. Now, because I need 1 more oxygen, so let me put this as 2 probably. Okay, so I have to add 2 more, so 18. Okay, so hydrogen is balanced, 2 here and 2 on the right. Now, so this is 1, okay, plus 1, 18. So number of oxygen are balanced, number of hydrogens are also balanced for both sides. Now let's check. U is 2 here. X is also 2. Okay. C is also 2. So number 1 is also correct. So the answer here for this question will be